Understanding microplastics and their ubiquity. Microplastics are tiny plastic particles, less than 5 millimeters in size, found in oceans, soil, air, and even food. These particles result from the breakdown of larger plastics or come from products like cosmetics and synthetic fibers. Their widespread presence has raised concerns about potential health impacts. How microplastics enter the human body. Microplastics enter the human body through ingestion, inhalation, or skin contact. They are present in seafood, bottled water, fruits, vegetables, and airborne dust. Once ingested or inhaled, these particles can travel through the bloodstream, potentially accumulating in various organs. Potential toxicity of microplastics. Microplastics often contain toxic chemicals such as phthalate, bisphenol A, BPA, and heavy metals. These substances may disrupt hormonal balance, damage cells, and interfere with normal biological processes, increasing the risk of health issues like cancer, infertility, and metabolic disorders. Impact on the digestive system. Studies suggest that microplastics may irritate the digestive tract, causing inflammation and altering gut microbiota. This disruption can affect nutrient absorption and immune responses, potentially leading to gastrointestinal disorders or chronic health conditions. Respiratory risks from inhaled microplastics. Inhaled microplastics pose a threat to respiratory health. These particles can settle in the lungs, triggering inflammation, irritation, or even fibrosis. Long-term exposure may exacerbate respiratory conditions such as asthma and chronic obstructive pulmonary disease, COPD. Potential effects on reproductive health. Microplastics may adversely affect reproductive health due to their endocrine-disrupting properties. Chemicals like BPA mimic hormones, potentially causing fertility issues, hormonal imbalances, and developmental problems in fetuses during pregnancy. Neurological concerns and brain health. Emerging research links microplastics to neurological risks. Certain chemicals in microplastics can cross the blood-brain barrier, potentially causing neuroinflammation and impairing cognitive functions. These findings raise concerns about long-term impacts on mental health and brain development. Challenges in assessing long-term impacts. Despite growing concerns, the long-term health effects of microplastics remain unclear due to limited human studies. More research is needed to understand their cumulative impact and potential interactions with other environmental toxins. Strategies to reduce microplastic exposure. Reducing reliance on single-use plastics, filtering tap water, and avoiding synthetic fabrics can minimize microplastic exposure. Governments and industries must also adopt policies and technologies to reduce plastic production and improve waste management systems. The urgency of global action. The pervasive nature of microplastics demands urgent action. Collaborative efforts among scientists, policymakers, and industries are essential to mitigate microplastic pollution, safeguard ecosystems, and protect public health from its potentially harmful effects.